the video you just watched with multiplying, dividing with exponents and negative exponents. When we have two terms with the same base, 2, and I'm multiplying, I can add my exponents. So 2 to the 4th power times 2 to the 6th power becomes 2 to the 10th power. When I have two terms with the same base again, and when dividing, I can subtract my exponents. So 2 to the 6th divided by 2 to the 3rd becomes 2 to the 3rd power. A negative exponent means that a number is less than 1. So when I take my negative exponent, I'm going to put it underneath the 1, so it's just going to become 1 over 4 to the 2nd power. We turn that negative 2 into a positive 2 and just make it in the denominator of a fraction. And then 1 over 4 squared, which is 1 times 16. And then lastly, we have anything to the 0 power is always 1. So 5 to the 0 power is 1. 11 to the 0 power is 1. Anything to the 0 power is 1. Now that you've learned a little bit about multiplying and dividing exponential expressions with both positive and negative numbers, we're going to do a little practice. So just for number 1, just simply simplify this exponential expression. So remember, anytime I'm multiplying two terms with the same base, they both have 4, all I'm going to do is add my exponents. So this simplifies down to 4 to the 8th power. And if we were to actually solve that, 4 to the 8th power would be 65,536. Again, that only means I'm doing 4 times 4 8 times. All right, same thing with number 2. Simplify this exponential expression. So again, I have the same base, so my base is going to be 6. And again, I need to add my exponents. Remember, when I don't see an exponent, it's like there's a 1 there. So 2 plus 1, my answer should be 6 to the 3rd power. And remember, this is because 6 squared just means 6 times 6. And then it said to multiply by 6. So I have 1, 2, 3 sixes. That's why my answer is 6 to the 3rd power. All right, write number 3. So remember, a negative exponent means that it's going to be a number less than 1. So I can rewrite this by starting with a 1. That's going to be my numerator. And the denominator is just going to be 3 to the 4th. So it's going to be the same problem, except the negative exponent will be a positive exponent in the denominator. And if I were to actually solve this out, 3 to the 4th power is 81. My 1 stays on top. So 3 to the negative 4th power is 1 over 81. All right, go ahead and simplify number 4. Again, so now when I'm dividing exponential expressions with the same base, my base stays the same, but I'm going to subtract my exponents, so I get 6 to the 3rd power. Solve number 5. Similar to number 2, when I don't have an exponent like this denominator, it's like I'm doing 3 to the 1st power. So 3 to the 5th divided by 3 to the 1st is really going to be 3 to the 4th. Again, we subtract our exponents when we're dividing exponential expressions. And lastly, go ahead and solve number 6. All right, so again, when I'm multiplying, remember I need to add my exponents. So my base is still 2, and it's going to be 7 plus negative 4. 7 plus negative 4, they're different signs, so I'll subtract, and I get 2 to the third power. Alright, so now we've got a few that are a little more challenging. Go ahead and solve and simplify number 1 on this slide. Alright, so this looks a little easier because I'm dividing. So I'm just going to subtract my exponents. Here though, 3 minus 5 is going to be a negative 2. So my answer simplified is 8 to the negative second power, and I can simplify that further by doing 1 over 8 to the second power, which is the same thing as 1 over 64. Go ahead and try the second problem. Alright, so we're going to take it one step at a time. First, I'm going to combine that numerator. I'm multiplying with the same base, so I'm just going to add my exponents. 5 plus negative 2. They're different signs, so I'm going to subtract. So my numerator becomes 2 to the third power. I'm going to divide that by 2 to the fourth power. When I'm dividing with the same base, I can subtract my exponents. 3 minus 4 is negative 1. So my simplified expression becomes 2 to the negative first power, negative 1 power, and I can write that as 1 over 2 to the first power, which is just the same as 1 half. Alright, and try that third one. Third one looks challenging, but those parentheses, remember, just mean to multiply. So I have 3 to the second power times 3 to the third power. Same base, so I'm going to add my exponents, and I get 3 to the fifth power divided by, the bottom I'm going to do the same thing. I have 3, or 3 to the first power, times 3 to the fifth power. Same base, I add my exponents, so I get 3 to the sixth power. I'm dividing with the same base, so I subtract my exponents. I get 3 to the negative first power, and I can write that as 1 over 3.